and good afternoon to all. And today we are going to discuss about 8051 microcontroller. And this IC is very important, and this has a great history in the invention and development of our lifestyle. And there are many facilities which improve our lifestyle much better, like microwave, water heater, and induction stove, and lightweighted mobiles, and these are all due to the IC technology development. And all these automated instruments are controlled by a small chip called as 8051 or 8085 microprocessor. And today we can see what is the architecture of 8051 and how we can make use of this 8051 much better by using the programming techniques. Let us we can go. First we have to know what is 8085 microprocessor. And here we can see, and it is a general purpose chip microprocessor, and with which we can add RAM, program memory, A by D converter, oscillator, and the other needs what we needed. For example, we can take a desktop computer, is nothing but a processor, central processing unit, which is connected with the input-output devices like keyboard, mouse, joystick, and output devices, monitor, and the memory can be added as we needed, like RAM and hard disk, so we can improve the memory still what we needed. So it is a general purpose microprocessor, and whatever we need we can add, like mouse we need means we can add, and if we need a keyboard if we can add, and these two are mandatory. If we need a joystick or memory devices externally want to connect means we can connect. So general purpose IC is called as microprocessor. So, and this particular microprocessor is used for CNC based machines or industrial applications, and which is generalized. We can customize according to the application what we need. And now we can see our topic is 8051 microcontroller. Now we can see what is microcontroller. And not like microprocessor, and we no need to add the RAM, ROM, timer, serial, input output, central processing unit, EPROM. And this all together embedded as a single chip. So we can call this as a single chip computer. Microprocessor, what is the difference between microprocessor and microcontroller? Here we can see the central processing unit with which we can connect whatever we need as input output devices. Where in case of microcontroller is all embedded in a single chip, here the memory is limited. And here we can improve the memory further. And here, if we need to improve the memory, it is limited. We cannot connect externally any of the memories or any other input output devices. This is the basic difference between the microprocessor and microcontroller. And here we can see the serial interface is given, and here also the serial interface connected. Input output is connected, and same input output connected, and CPU is connected, and same CPU is connected. What is here the difference? The difference is the memory, and we can have more input output lines, input output pins in the microprocessor, where in case of microcontroller it is not available. It is all limited. Memory is limited, timers are limited, counters are limited, serial interface communications are limited. So because of these limitations, microprocessor finds application at industry level, and microcontroller finds application at the domestic and low cost based instrument development side. And here we can see the von Neumann and Harvard architecture. This is very important because as we are going to discuss about architecture of microcontroller, we have to know about what is the architecture which is inbuilt for 8051 and how it is working. And basically there are two architectures. One is von Neumann, another is Harvard architecture. And here in the figure we can see the CPU, and here there is called as memory, program and data memory, which are a same memory. There is no separate memory for program and data memory. So the CPU fetches the instruction, and it will search for the data, and will process in the CPU like arithmetic logic operation, and again stores in the memory. So here we are having provided only one bus and one memory. So here we can see in the hardware architecture, it is not like the von Neumann, a central processing unit which having two memory. At a time, at parallel, we can stretch, we can take the instruction, and we can process, and we can load the data, 8-bit data. So here we can compare through the memory itself and here we can do the operation. Because of this we can increase the speed, we can do much faster, like your mobile. For example, we can take a mobile. If we are listening to the music and if we are surfing to the internet, if a call comes, the priority is given to the internet call. And we can do, while we are surfing internet, we can also listen to the songs. So that is called as multitasking, and this is happened due to the hour architecture. And microcontroller development, how the microcontroller families developed, IC developed. And initially the microcontroller starts with 8031 40-pin IC, and here no on-chip program is provided, and here the data memory is 128, number of input output lines is 32, timers and counters is 2 and 1. This is the initial stage, and it is improved to 32, and here we can see the memory is improved to 256, and the number of input output lines is same, but however the timer is improved. And 8051, here we can see the difference is, here we are having on-chip program memory is given, where in case of 8031 and 32 the memory is not provided, and here the data memory is 128 and 32, and timers and counters is 2 and 1. So you can see 52 and 54, 751, and as long we can see the improvement is with the on-chip memory. Here we can see the ROM, and the rest is EPROM, and flash is the latest one. So we can erase the memory what we are storing in the RAM by a simple flash type, electrical flash. And this is a pin diagram of 8051, and basically IC have pins, and which is assigned with the input and output pins, and we can connect whatever the input, like solar panel signals, and we can take outputs as motor, LED, LCD, 7-segment displays. These are the outputs, and we can give the supply and the ground, and the reset pin is there. If there is a problem occurs, and we can press the reset button, or for any program starts, just the chip will initialize with the reset button. And next one is crystal, and crystal is the heart of the any microprocessor or microcontroller, and that gives the rhythm of frequency at which we can make the speed, or we can calculate, or the system gets the speed by using the crystal. And these are all control signals, and with which we can use of the external memory. So here we can see the port 0, port 1, port 2 and port 3, and these are input output ports, and able to connect the input output external world, and we can control over the devices like motor, lights and fans, etc. And pin number, we can see here according to the pin number, and what are the facilities, what are the ports assigned, we can see here. 40th pin is VCC supply, and 20th pin is ground, and here 18 and 19 is crystal, and here we can see the port zeros are from 0.00 to 0.07, and port 1 is from pin 1 to 8, there is one port 1.0 to port 1.7, and reset button is here. So port 3 is assigned here from pin number 10 to 17, and port 2 is assigned from 21 to 28. So this is the pin configuration, and by knowing the pin details only we can able to design any hardware. Unless without knowing the pin details we cannot connect the input and outputs. So it is necessary to know the pin details. Without knowing the details we cannot make a design. And this is schematic diagram of architecture of 8051, and very important thing is, for any processor or controller is CPU, central processing unit, and that can process any arithmetic and logic operation. And if you want to run a motor, it's a digital one, or we have to run the motor by giving 0 1 0, so we can switch on off, or we can make continuous on, again we can off. So this all happens by storing the data in a memory, again we are recalling and we are running the motors. So this is possible only by processing by central processing unit. So here we are having the very important on-chip memory ROM and RAM. Here we can store the data, and timer is given as 1 and timer 0, and this also can be used as counter by choosing a simple chip select option. So we can use the same option as for timer and counter. And here we are having interrupt control, oscillator called as crystal, that gives the heartbeat of the microprocessor or microcontroller, and bus control, and input outputs. Here we can connect what are the inputs and outputs like motor, LED, LCD, 7 segment. We can connect any sensors, all those things can be connected here as output device, and serial port here like USB and other set of serial can be connected here. And here we can see the timer is given. So timer is meant for a particular application. Suppose we want to count the number of bottles is filled for a particular applications, there we can use of timers. Timer, 2 timers are provided. And here interrupt is given. Suppose you are programmed to control a motor and it is running, but suddenly if you want to stop for another process means we can give an interrupt facility. There are 4 interrupts are available, and interrupt 1 has the highest priority, and the program will give the highest priority interrupt and stops the regular program and gives priority to the interrupt, and the interrupt program will run, and then after the completion of interrupt the other programs will start running. And here the serial port is given for communication purpose. And nowadays we are provided with the USB connections. In the USB we are having 4 pins. There is a plus V and minus V supply, and D plus and D minus called data. We can transfer the data. And here we can receive, transfer and receive data bilateral between the master and slaves. And these are all ports, 4 ports. And this is the actual architecture of 8051. And here we can see the memory RAM, and here we can see the accumulator, ALU, and program status board, and the input output ports. There is port 0, port 2, and port 1, port 3. So port 0, 1, 2, 3, and memories and control signals and arithmetic logic unit with the program status board and timing controls. And here we can see the program registers, buffers, and incrementer, program counter, DPTR. So this DPTR is meant to know what is a program which is running, okay, by with the program incrementer and program counter, and that will select the particular instruction, and in the memory we will find the particular data and will be processed in the accumulator and will be stored and will be given as the output in the any of the ports. And memory map. And here we can see there are 2 memories. One is data memory, another one is program memory. And data memory, here it starts with the address 000 and FFF, and the program memory starts from 00FF to 1000 and FF. This is internal memory and this is external memory. Here it is given EA equal to 1, that is called internal, the selection of internal memory. Suppose if the memory is not enough for us, we have to go for the external memory. So we can have the code of EA equal to 0, that is called as external memory. And in the internal memory you can see it starts with the 00 and end with the 7F, 82 FF. So this is data memory and this is special function registers. So this all called as control signals, and we can specifically program our output with bit address. And now we are going to see what is this particular internal memory map. So already we know the address starts from 00, 7F, 80 and FF. So data memory and special function registers, and here we can store any of the data like arithmetic logic operations, and we can store temporarily. Suppose we want to call a particular address called as timer, or we want to access a serial communication, we can use this special function register. For each and every special function registers have been given a bit address. So we can call the particular address and we can assign the output directly. So this is called as special function registers. And here we can say data memory starts from 00 to 7F, that we have the same address, but here it is even in depth it is explained as bank 0, bank 1, bank 2, bank 3, and this is scratch pads that is used by the industry persons. We cannot access that. So we can use these bank zeros 1, 2, 3, and further these banks are divided into registers as R0, R1, R2, R3, R4, R5 up to R7. So these are called as registers. So each banks will have these kind of registers. There are 4 banks are available, and this is scratch pad. This is called as internal map, internal memory map. And now we are going to discuss about special function registers. Here, as I said, we are having the control signals like TCON, timer, control, timer mode, and data pointers lower and middle, and here we can see the timer low and high, and power control, stack pointer, and here we can see the serial control and interrupt enable, interrupt priority, program status board, accumulator, B register, and this B register is used for division and multiplication. And if you want to make any arithmetic operations, there are 4 set of things are available. What is addition, multiplication, division and subtraction. If we are using addition and multiplication, we can make use of accumulator. If you want to do the division and subtraction, and the data will be stored in the B register. And for addition and multiplication will be stored in accumulator. For division and subtraction will be stored in the B register. And status word register. What is the status word register? And basically the status word register is nothing but, and what is the activity which is going on in the 8051, that we can know in this program status code. If there is an addition and there will be carry. Okay, so we can know what is the carry, what is the auxiliary carry, and where is the overflow. Those microcontroller operation can be seen in the program status code. And this is interrupt priority. As I said, interrupts are given 4 levels, and for which interrupt we have to give, the priority is given here. Interrupt enable, we have to enable that. And this is what we call as ports P2, P3, P0, P1 are ports, and we can call a particular ports, or we can assign a particular ports for a particular output. Suppose if you want to connect a sensor, or if you want to see a light is LED is glowing for every 10 seconds, and we can control over the port P0, means we can assign directly the address 8080. Okay, so that particular address can be programmed in such that particular LED is connected to the 80 address. So we can see the output of the LED glowing for every 10 seconds. And suppose we don't want P0. If you want to connect with P1 means we have to go with the register. There is a register address as 90. So these are all register address. And these are all B register, accumulates memory, and program status code knows the status, and interrupt priority. If the program has the other important roles of urgency call, means we can use the interrupt priority, and interrupt enable. We have to enable the interrupt, other we have to give priority, and serial communication is also possible by using serial control, serial buffer. And here we are having timers and timer based registers and data pointer for showing what is the particular sequence of highest address is going on. Stack point. If we want to add 1 plus 1 or 1 minus 1 plus or 1 minus, we can use stack pointer, and power control is here. And since the very most advantage of using microcontroller is it doesn't require 2-3 volt with basic small battery itself we can run this microcontroller. So there is a almost very important advantages. And however this IC is specifically also with the micro P control. If the power is very less, and which will optimize itself with this particular options P control. So the address is given is 87, and this is bit addressable location. And even if we want to generalize, if you don't want to use the specialized address of serial, timers and interrupt, if you are going to generally store your data and you are going to acquire for an output, means we can use bit addressable locations. We can store wherever we need this bit addressable. Bit addressable means particular address we can use, and non-bit addressable means we have to send all 8 data stored in a banks of the registers. But bit addressable is not like that. We can assign each and every bit for a particular output. For different outputs we can assign. That is possible by using bit addressable locations. And next one is flag registers PSW. As I said, we can know what is the status of the microcontroller programming by using this particular register. It starts from D0 to D7. D0 is parity, and D1 is user flag, and D2 is overflow, and D3 is here. D3 and D4 is select option. Which bank we are going to select? Where we are going to store the data. So bank 0 is 00, bank 1 is 01, and bank 2 is 10, and bank 3 is 11. So here the fifth one is user flag and auxiliary care, and this is carry. So here we can know what is the condition of the carry if there is an addition. Okay. And next one is stack pointer. In this architecture, A small part is called a stack pointer, and which is 8-bit register, and which with the initialized address of 707H, and actual location starts from 80H, and SP is stack point is increment by push or pop up. We can add 1 or we can minus 1. So like that we can add and we can increment the program and we can activate the desired output. The next one is data pointer, and here we can see data pointer is here, and this is 16-bit address, and since it has a good memory and it is possible to go for 16-bit address, and with that address we can find out the location where the data is stored, and we can recall, we can process, again we can give or control any of the devices or instruments. And maybe use 2 8-bit register. We cannot, if you don't want to use 16-bit, we can use as 2 8-bits. One is DPH, another one is DPL. Data pointer high and data pointer low. And next one is input output port. And here we can see how many ports are there? 4 ports. One is port 0, port 1, port 2 and port 3. 4 ports are there. And these 4 ports are connected with the latch. And these latches are important. Sometimes the output in device which is connected may not have sufficient power to extract that. So we are having the latch which is connected, and here these are all TTL based input, and output is open range outputs, and here having 4 input output ports. And next one is clock, and that is generated by crystal with the capacitors. In hardware, crystal is there, and we have to connect the capacitors, and that will produce the heartbeat to the timing and control circuits, and that will make the rhythm of the particular speed. And there are crystals available in the market of 12 MHz, 20 MHz and 48 MHz. So the hobbyistic person or the person who develops the instrument will buy the crystal, and they will connect with the capacitors and generate the timing and control circuits. Here we can see the machine cycle contain 6 states. And user cannot access the Intel clocks. Yes, we cannot access. We can fabricate in the instrument as a hardware, and we can create the frequency is off of the oscillator frequency. And next one is Boolean processor. And basically the microcontroller will process the arithmetic and logic operations. How we can do that? We can make input output, bit addressable RAM, carry flag, accumulator and instruction set. With this we can process the basic arithmetic, that is addition, multiplication, subtraction, division, and logic operation as AND gate, OR gate, and the other logic gates based applications also can be, logic also can be executed in the microcontroller by knowing the instruction sets, and with the use of these accumulators and input output ports. And here you can see the next topic is control register. T mode, timer. T control is also a timer. If you are going to use the timer, and we have to use this particular register to transfer and the timing sequence to control the output devices, and serial control for transfer of bits in terms of communications like USB, and interrupt enable and interrupt priority. This will disturbs the regular programs and gives the importance to the emergency programs. If there is a accident occurs in industries, the others called as measures should be provided by the logics, that is called as interrupt priority programs, that will take place and stop the regular programs, and that will implement the sensors, the other measures to troubleshoot that. That is called as interrupt enable and priority. With that we can execute the program. And next one is power control. This is very important for any ICs, since power is a very important thing. If there is no power, we cannot run the system. So it is necessary to optimize by using the power control. And next one is timer mode register. And here we can see 2 timers are here, timer 0 and timer 1. Timer 0 means D0, D1, D2, D3. And timer 1 is D4, D5, D6, D7. 2 timers are provided, and here which timer we can select based upon the selection of M0 and M1. So M0 and M1 is given here, and 00 means 8-bit counter, and 01 means 16-bit counter, and 10 means 8-bit auto reload, and 11 means timer 0. And here we can select which mode, 8-bit or 16-bit, or it's auto reload, or it's a timer 0. So this all depends how we are selecting these modes. And here you can see counter and timer, whether we are going to use this as a timer or counter. So it all depends upon how we are choosing. If it is 1 is selected as 1 means it is counter, and if you are selecting 0 means it is timer. And gate, and this will control the rest of the operations based upon the application what we needed. So here we can see is a 8-bit register D0 to D7, and here two modes M0 and M1 is provided, and we can select the timer mode, and we can make use of the timer based application. If you don't want timer, and we can select the counters by choosing this D6 as setting 1 or 0. And next one is timer control, and we have to certainly control the time based applications. There are 7, there is D0 to D7, it is D0 to D7 here, 8 bits are here, and here we can see the set of instruction with which we can set the timer control. Here we can see IT interrupt priority and interrupt enable, interrupt priority and interrupt. So here we can see two interrupt or interrupt enables are here, 0 and 1, and flags are here. So if there is a flag set, if timer is set for number 20, it should not overcome. And if it is 20, and the counting should start from 0, 1 and should go 10, 15 and 20. If it is crossing the 20, again it should reset. Okay. So timer overflow is given. Two timer flows overflow is given, and register is given with interrupt priority and enable is also given. This interrupt priority and enable will control the whole process. And here we can see the timers are again two types, timer 0 and 1. 4 modes are there, mode 0, mode 1, mode 2 and mode 3. In the before slide we have discussed about this in detail. So 4 modes are here, and those 4 modes are discussed here as mode 0, mode 1, mode 2 and mode 3, and 8-bit. And here we can see 16-bit timer, it's a 8-bit timer, and mode 3 is timer 1. And here what is the necessary thing means we have to select which timer we are going to use. Two timers are provided. And if you want only timer 0, we have to select in such that the mode should be selected 0. And next one is serial data buffer, and this is very important. And the latest instruments developed with developed with serial communications, and whatever we are doing the operation, it should be stored in a computer or any other devices. So we need a serial communication for that. And here we can see this is called as control blocks, and here we are having serial buffer and serial control. 99 is the address for that, and two registers are there. One is transmit buffer, another one is receiver buffer. And 4 modes are there, mode 0, mode 1, mode 2, mode 3. And mode 0 here 8-bit, and mode 1 10-bit, and mode 2 11 bits, and mode 3 similar to mode 2, and baud rates are variable. So baud rate is nothing but how much the data is transferred to the receiver end. And this is serial control, and here this is 8-bit and with the same interrupt priority and enable. And here we can select the mode by SM0 and SM1. Here we can see the baud rate. Based upon the baud rate, we can classify the modes: mode 0, mode 1, mode 2 and mode 3. Okay, so here we are having 8-bit UART and 9-bit UART and 9-bit variable UART. Interrupt enable register, and here the interrupt enables are classified in two types, and ETO and ET1, ET2, and there is ETO, ET1, ET2, and X means external interrupt. And here this is for serial interrupt, and this is for overall we can make 0 as disable all interrupts, and 1 means enables. With a single set point we can enable all those things, and with a single set point of 0 we can deselect all the bits. Okay, and here we can set the interrupt in such that by selecting the modes. interrupt priority registers, and here already as I said, the interrupt priority means we have to give the priority for the interrupt levels, and there are set of programs which should be given a priority. For example, if we are listening to a song in mobile, if a call comes, the mobile gives priority to the calls. That is called as interrupt priority. So priority means the preferences will be given to the first very important operation, the rest will be given. So it will stop the regular actions and gives the importance. That is called as interrupt priority, and this register is meant for the interrupt priority. Here it is synchronized with the timer and interrupt 0, and serial port interrupt high priority, and here we can see the highest priority as like this, and lowest is this, and highest is this. And thank you.